Artificial intelligence called in to tackle LHC data deluge. Algorithms could aid discovery at Large Hadron Collider, but raise transparency concerns. By Davide Castelvecchi in Nature magazine, December 1, 2015. The next generation of particle collider experiments will feature some of the world's most advanced thinking machines, if links now being forged between particle physicists and artificial intelligence, researchers take off. Such machines could make discoveries with little human input, a prospect that makes some physicists queasy. Driven by an eagerness to make discoveries and the knowledge that they will be hit with unmanageable volumes of data in 10 years' time, physicists who work on the Large Hadron Collider (LHC) near Geneva, Switzerland, are enlisting the help of experts. On November 9 to 13, leading lights from both communities attended a workshop, the first of its kind, at which they discussed how advanced techniques could speed discoveries at the LHC. Particle physicists have realized that they cannot do it alone, says Cécile Germain, a computer scientist at the University of Paris South in Orsay, who spoke at the workshop at CERN, the particle physics lab that hosts the LHC. Computer scientists are responding in droves. Last year, Germain helped to organize a competition to write programs that could discover traces of the Higgs boson in a set of simulated data. It attracted submissions from more than 1,700 teams. Particle physics is already no stranger to in particular, when Atlas and CMS, the LHC's two largest experiments, discovered the Higgs boson in 2012, they did so in part using machine learning, a form of that trains algorithms to recognize patterns in data. The algorithms were primed using simulations of the debris from particle collisions, and learned to spot the patterns produced by the decay of rare Higgs particles among millions of more mundane events. They were then set to work on the real thing. But in the near future, the experiments will need to get smarter at collecting their data, not just processing it. CMS and Atlas each currently produces hundreds of millions of collisions per second, and uses quick and dirty criteria to ignore all but 1 in 1,000 events. Upgrades scheduled for 2025 mean that the number of collisions will grow 20-fold, and that the detectors will have to use more sophisticated methods to choose what they keep, says CMS physicist Maria Spyropoulou of the California Institute of Technology in Pasadena, who helped to organize the CERN workshop. "We are going into the unknown," she says. Inspiration could come from another LHC experiment, LHCb, which is dedicated to studying subtle asymmetries between particles and their antimatter counterparts. In preparation for the second, higher energy run of the LHC, which began in April, the LHCb team programmed its detector to use machine learning to decide which data to keep. LHCb is sensitive to tiny variations in temperature and pressure, so which data are interesting at any one time changes throughout the experiment, something that machine learning can adapt to in real time. No one has done this before, says Vladimir Glagorov, an LHCb physicist at CERN who led the project.